Hello, welcome to Chapter 13, Section 6, the tangent function. Now, the tangent function is the line that's tangent to the unit circle, okay? And it'll happen everywhere. So, and it's where the tangent line intersects the line of the angle, okay? And you don't really have to be able to figure that out. Just know what it means for now, and be able to draw it. Okay, and this is what it looks like. It's very different from sine and cosine. Now, a period on a tangent function is actually from one asymptote to another, and they end in asymptotes. So this is a period. Okay, and you can see how you get all the points, and it's all dependent on its relationship to sine and cosine, and we'll talk about that more when you get into pre-cal. All right, so for now, our goal is to let you know what it looks like, find the period, be able to see, where the asymptotes are, and the cycle. Okay, and the cycle in this case is going to be from negative pi over 2 to pi over 2. Okay, that's one cycle, because that's one period. And that's one period. So, let's answer some questions. Now, if you look at this, pi over b is the period of the function. One cycle occurs in the interval from negative pi over 2b to pi over 2b. Okay, and that's just one of them. And that's pretty much just the one that's centered around the origin. They can happen elsewhere, and they will, because it'll repeat. Just like sine and cosine repeat forever and ever, this will repeat forever and ever, and it'll have an infinite number of asymptotes. So it really doesn't go to one thing as you go as far to the right as possible. Okay, it's pretty much undefined at that point. So first it says sketch two cycles of the graph of y equals tangent of theta over 2. They give us b. The amplitude is a, but it's not going to affect what you see in this class, at least. You will see more when you get into pre-cal, but for now, it's just 1. The period is going to be going from a negative number to a positive number. So first we need to figure out what the period is. So if b is 1/2, then when you plug in 1/2, you get pi over 1/2. And remember, when you divide, you're secretly multiplying by the reciprocal, which is pi times 2 over 1, which is 2 pi. Okay, so it'll take 2 pi to get from one side to the other, from one asymptote to the other. Now the difference is that asymptote is not going to happen at 0. We're not starting at 0. We are going to go through 0, though. So let's put a point right here. Okay, so we need to figure out where the left asymptote is and where the right asymptote is. The left asymptote occurs at negative pi over 2b, so 2 times 1/2. Well, that's just 1, so it happens at negative pi. So our left asymptote is going to be at negative pi, so I'm going to draw this vertical dotted line. All right, let's find the positive one. Well, that's pi over 2 times 1/2. Right? The difference is the sign. And so that'll cancel, and we'll get pi. So it'll happen at pi. So let's go to pi and draw that. And that makes sense because the distance between negative pi and pi ends up being 2 pi. Right? That's that whole distance. And so this graph is going to look like this, and it's going to go up and follow the asymptote, and down and follow that asymptote. And if we have to draw 2 cycles, then we need to go over 2 more pi. Right? And so instead of it being at pi, it's going to be 2 more, so pi plus 2 pi is 3 pi. And so you'll have another asymptote here. The point in the middle, where it crosses the x-axis, is going to be right in the middle, and it'll follow this one up, and that one down, and there we have 2 cycles. Okay, and it's pretty much that straightforward. You just have to pay attention to how large the period is. And when you come up with the equation based on the graph, a is going to be 1, and so all you have to worry about is your period and b. Well, the distance from here to here is 2, which means that the period is 2. Well, if the period is 2, then pi over b is the period, then pi over b equals 2, which means that pi equals 2b, and b equals pi over 2. All right, so when we go to write our equation, we're going to write y equals, the amplitude is just going to be 1, because there's not really 1, right? So a is just going to be 1. So we're going to have tangent of pi theta over 2. And that's it. And the last thing I'm going to ask you about tangent is going to be something like this. So an architect is designing the front facade of a building to include a triangle, as shown in the figure. The base of the triangle is 200 feet wide. The function y equals 100 tangent theta models the height of the triangle, where theta is the angle indicated. What is the height? Okay, well, this models the height. What is the height of the triangle when theta equals 18? And what is the height when theta equals 20? So guess what we're going to do with theta? We're going to plug it in, and that's it. You're going to plug it into your calculator. So y is going to equal 100 tangent of 18, and that's in degrees, so make sure you change your calculator to degrees if it's not already in it. And y equals 100 tangent of 20 degrees. We're going to get an approximation when we plug it into the calculator. So let's put approximately. This is 32.5 feet. That's what your calculator would give you. And this is 36.4 feet. Again, that's what your calculator would give you. So even word problems aren't that bad. All right, and that's it. Have a great day.